Hi everybody, so in this video we're going to look at equality of complex numbers. So that's just a way of saying an equation that involves having a complex number on one side or both sides. So this is an example of an equation where we have a complex number on either side. You can see we have a real and imaginary number on the left hand side and a real and imaginary number on the right hand side. And we're being asked to solve for x and for y. So we're going to need to use equality of complex numbers to do that. Now, what this whole topic is basically about, and the easiest way to solve the question, is by just realizing that if this complex number is equal to this complex number, then the real part of the complex number on the left hand side has to be equal to the real part on the right hand side. So the real part on the left hand side is 5. The real part on the right hand side is minus x. The imaginary part on the left hand side has to be equal to the imaginary part on the right hand side. So 3y has to be equal to 6. So it's important to take a note of that and remember that the real part on the left hand side is going to equal to the real part on the right hand side. The imaginary part on the left hand side is going to equal to the imaginary part on the right hand side. Again, up above here, I've just highlighted the real parts in green on each side and the imaginary part in red on each side. Now to solve for x and y, what we're going to do is set up two smaller equations. We're going to let the real numbers equal each other. So we can let 5 equal to minus x. And we're going to let the imaginary numbers equal to each other too. So 3y is equal to 6. Now these are each an equation because they have an equal sign and they have their unknown variable, an x here and a y here. So all we have to do now is solve out each of those. So to solve 5 is equal to minus x, we can multiply each side by minus 1. This will give us minus 5 on the left hand side and plus x, or just x on the right hand side. Remembering that a minus times a minus cancels out to give us a plus. On the right hand side, to get y by itself, we can divide both sides by 3. So when we divide 3y by 3, we're just left with y. When we divide 6 by 3, we're just left with 2. So we find out that x is equal to minus 5. And that y is equal to 2. So we've figured out the value for each variable as the question asked originally, solving for x and y. So we know that we've done what that question wants us to, and we can move on now. Okay, so we'll look at a second example now that uses the same principle. This equation looks a little bit more complex because there's more writing on the left hand side than there was in the last question, but the same premise applies here and the same way of solving it also applies. We've got to realize that the real number on the left hand side is going to be equal to the real number on the right hand side. So 7a on the left hand side is going to equal to 14 on the right hand side. Now the reason why this one looks a little bit different is because the imaginary number on the left is written out a bit different. 3a minus b is the imaginary part, and like before this is all multiplied by I, but it's just recognizing this whole bracket here is the imaginary number, and it's not just one number next to the I, it's two terms. Then on the right hand side, minus 6i is the imaginary number. Now it's important there to pay attention to the signs. Whenever you do see a negative sign, just make a note of it and make sure you carry it down with your work. So we're going to create our two equations now. We can say that 7a is equal to 14, and we can say that 3a minus b is equal to minus 6. Again, like before, we don't include the i's here when we're writing out the imaginary parts. So on the left hand side, if you want to solve for a, you want to get a by itself, so we'll divide by 7. We have to divide by 7 on the right side too. So 7a divided by 7 just gives us a, and 14 divided by 7 gives us 2. So we know that a is equal to 2. On the right hand side, we have 3a minus b is equal to minus 6. Now, there's actually two unknown terms here, so we'll have to look over to the left hand side and fill in a as being 2. So we can solve this whichever way we want. I think the first thing I'm going to do is do the multiplication out though. So 3 times 2 is 6. So then we have 6 minus b is equal to minus 6. Then I'll keep the minus b on this side and I'll bring 6 over. So we have minus 6. When 6 comes over here, it's going to change sign. So that's also going to turn into a minus 6. Solving that out a little bit further then, minus 6 will be minus 12. Then I can divide both sides by minus 1. So the minus and minus will cancel here, and I'll be left with b. On the right hand side, minus 12 divided by minus 1. The minuses will cancel, and 12 divided by 1 gives us 12. The reason why the minuses cancel for both of these is that a minus divided by a minus is a plus, so we're left with plus b, and a minus divided by a minus is a plus, so we're left with plus 12. So we know that a is equal to 2 and b is equal to 12, and there are two answers we've solved for both of those unknown variables.